All right, we are going to talk about real quick here, just a quick question that came up from students, a concept question. And this is the question here. The concept question is, why do we have, along the x-axis, why do we have things that have a pi inside them? So, such as something like this, pi over 2, 3, pi over 4, pi, and then it just kind of keeps on going. In fact, I do want to go out to 2 pi, because there's a reason for it. So this would be 3 pi over 2, because that would be half of it. This would be what? If this is 4 pi over 4, that means the next one would be 5 pi over 4. This would be 6 pi over 4, which is true, because if you divide it by 2, it'll get you 3 pi over 2. And then the next one would be, let's see, 6 pi over 4, 7 pi over 4 would be right here. And what do you know, 8 pi over 4 would be right here, which would actually just be 2 pi. Okay, so, but the question is this, why do we have pi values inside the x-axis? And then another question is, how do we get rid of them? Or when do we get rid of them? So let's go for it here. First question is, how do we get them in the first place? So if you think back to the unit circle, now I'm only going to do this with sine, but you can do this with cosine, with tangent, all the other ones here. So we're going to take this, and we're converting it to this. We're going to go off the unit circle. We've been working on the unit circle. Remember, on the unit circle means you have exactly a length of 1 for your r value, or the distance away from the origin. Okay, so that's what we got there. And so when we did this in class, we actually took it at a 30 degree angle first here. So let's try this here. So I'm going to plant different. That'd be 30, or pi over 6, pi over 4, pi over 3, and pi over 2. And then remember, it keeps on going, right? It keeps on going like this all the way out. So we're going from unit circle, and we want to go to a coordinate system, or the Cartesian, the old word for it, Cartesian coordinate system. Okay, so answer the question, where do the pi values come from? So if I were to make a chart of the sine values here, so this would be, first of all, we'll start off at 0, 0. This guy is going to be 1, 0. This guy is going to be the square root of 3 over 2. This will be 1/2. Once we get to 45 degrees, or pi over 4, we're going to be a root 2 over 2, another root 2 over 2. Once we get to pi over 3, or 60 degrees, we're going to be at 1/2 comma root 3 over 2. And then eventually we're going to get to 0, 1. And then notice it's going to go down again. The y values are going to be the same. So the y values here are going to be, it's going to be a negative 1/2, but it'll be a root 3 over 2. We're going to go just to pi, because the rest of it we can do. Negative root 2 over 2 and root 2 over 2. And a negative root 3 over 2 comma 1/2. And then eventually we get ourselves a negative 1, 0. That should be negative 1, 0. Okay, so let's go for it here. So instead of calling it theta, which is our angle measurement, since we're trying to move to the Cartesian coordinate system, we're going to call it x. So x is the input, x is still the angle measurement, and then we have sine of x is the output value. So if we say 0, if we go over here 0 degrees, in fact, you can look at the unit circle in back of your textbook. It's in the back cover of your textbook. It has all that right there. And then just kind of flow through it, just like this here. So at 0 degrees, or 0 radians, we have a sine value of 0. Always the y value. Along the unit circle, it's always the y value. So at pi over 6, which is this little angle measurement right here, we get ourselves a value of 1/2. At pi over 4, we get our angle value of root 2 over 2. And then at pi over, let's stretch this out now, at pi over 3, we get our angle value of, the angle value of pi over 3 gives us a ratio of root 3 over 2, and all the way down to pi over 2, we'll just keep on going with this, we get ourselves a 1. And then notice after that, which would be what? Which would be this little guy right here. This would be 3, 2, 2 pi over 3. It gets you that one. And then at 3 pi over 4, it gets you root 2 over 2, so on and so forth. Okay. So the x-axis, that's where these guys come from. There's your x-axis points. Now I did make it pi over 6, so pi over 6 is about right here. Pi over 8 would be half, so pi over 6 is about right there. Pi over 3 would be this broken up into, so pi over 3 about right there. It's a little bit past pi over 4. Let's see what else we have. 2 pi over 3, right? This would be about right there. And this is 5 pi over 6, which would be it would be right here. This is 5 pi over 6. Okay, so how do we do this here? Let's go for it here. So notice the sine is only going to stretch out to 1 and -1. We talked about that. The maximum value sine gets is 1. The minimum is -1. And so we plot these points now. 0, 0 is right here. 0 sideways along the x-axis and 0 up. At pi over 6, 1/2, we're going to go pi over 6 and we're going to go about halfway up right here. At pi over 4, it's root 2 over 2, so do that on a calculator just real quick here. I think it's going to be a 707. So 7.7 is usually what we do. We don't even go that precisely to the hundreds place, just the tens place. And at pi over 3, root 3 over 2, again, punch that into a calculator. And I think it's about like this, right? 0.866 or something like that. So close to 0.9. So we have something that looks like that. And at pi over 2, we get ourselves the 1 value. And then we just keep on going. So notice this is just going to go down back to 0.866 or 0.9. At 3 pi over 2, it's going to go back down to 0.7. Then we get ourselves, at 5 pi over 6, we get ourselves a half, and then we get ourselves 0 here. So then as sine goes underneath, it's going to repeat itself the same exact way till it gets to -1. And it's going to come back up until it gets to 0. So if we do that, go down to -1, and then come back up to 0. We can fill in the other little pieces if we wanted to. We can fill in those pieces. But essentially the sine curve goes like this. And I think the question off the person was, why do we have pi values along our x-axis? It's because of those radian measurements of our angle. And you should kind of have an idea of what the angle measurements are, right? So pi is roughly 3.14. That's kind of what's happening in your mind. Okay, about there. That is 1.57, because you take half of pi, that would be 1.57. So roughly that's kind of where you're at. Okay, the other thing I should mention is your scale for your y-axis and the scale for your x-axis don't have to be the same. I know in algebra, remember, the scales are usually the same. In this case, as long as you draw out the x-axis well, as long as you draw out the y-axis to what you need for the problem, that's all you're looking at. So let's do maybe 2, maybe 3 problems here. Let's graph something like this. And we'll do the graphing aspect. So it's 3 multiplied sine of x. So you could put parentheses if you like right over here. But there's a multiplication between the 3 and the sine. So the way we normally graph these is amplitude goes first. And amplitude is, well, let's do this here. There's my a value. My b value is the number that's multiplying the x. It's the multiplier to the x. In this case, it'll be a 1. So amplitude, here's some formulas. Amplitude is the absolute value of the a value. So in this case, absolute value of 3 is 3. The period is going to be 2 pi. Remember, that's the original, if we go back in our slides, right? That's the original period that we normally have for sine. And this is divided by b. Since b is the one that multiplies the x, it actually, the bigger the number, it actually shortens the period here. So in this case, it's 2 pi divided by 1, or just 2 pi still. And then the only other thing that we kind of do before we do the tougher stuff here is we talk about whether there's a reflection. So the question is there a reflection? And reflection means if there's a negative right there. Does 3 have a negative next to it? And if it does, then there's a reflection about the x-axis. In this case, it's a no, because 3 is positive. All right, the other stuff you got to learn in the chapter are phase shift. How does that work? And vertical shift. That's it right here. So graphs, all graphs are based upon those 5 pieces. So let's go for it. Let's graph this sine curve. So now, own little pieces, you got to think about sine curve. Sine curve again, it's the normal process is it stretches out to 2 pi. We cut these guys always in half. Cut these in half, and these are called critical points. So pi over 2, 2 pi over 2, then this is 3 pi over 2. And that means this is 4 pi over 2, right? It just kind of goes up by pi over 2s. Okay, and then the normal curve goes up to 1, as we saw, down to negative. So these guys are called critical points right here. So 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, negative 1, and 2 pi comma 0. So when we think of graphing a sine curve, we think of this guy initially. So what does our curve look like? Well, it's going to have a period of 2 pi, so that does not change, and we're going to divide it into 4 pieces. So half of that, and then we get this little, the only thing missing is that little middle section right there. So we normally go, if this is our unit value, pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. That totally makes sense. Okay, since we have to go all the way up to 3, what we do is we just condense this scale down. So 3 is going to be here for us, 1, 2, 3. 3 is going to be here for us here. So the scales don't have to comply with what the x scale is. And that's it. So what we do is we just transfer. So this little 0 marker gets transferred here. Don't think we've got to worry about. So we took care of this right here. I'll talk about the reflection a little bit later on. But we took care of the period by setting up our scale for our x-axis. And then we take care of the amplitude by the next point that we're going to choose to go with. So original graph is at pi over 2, 1. Now it's going to be at pi over 2, 3. The next point is at pi 0, still at pi 0, because amplitude does not affect where the zeros are. Okay, and at 3 pi over 2, negative 1 for the original graph, so 3 pi over 2, negative 3 for our graph, and back to 0 once we get to 2 pi. Done. There's my sine curve. Voila. Da-da-da. Okay, let's do another one here. How about if we stick a little negative in there? Let's see how that changes things. So negative 3 sine of x. Negative 3 sine of x, and I'm going to go a little faster here. Less explanations, more doing. Again, that's my a value, that's my b value. So absolute value of a, absolute value of negative 3 is 3. That's my amplitude. I'm going to go up from the middle. So this is what amplitude means. I go up from the middle 3, I go down from the middle 3. And that's my little middle value here. Period. Again, 2 pi divided by b. In this case, it's 2 pi divided by 1. No change to my period. Good. And then now, do we have a reflection? Okay, reflection, yes we do. That guy is a negative. I'm not going to talk about phase shift. I'm not going to talk about vertical shift. That's later on in the chapter. But you do have to get those in your mind as well. So, here's what we got. Original sine curve. 1, negative 1. So originally it goes like this. Here, 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 here. Except now we have ourselves the reflection. So when we be graphing this, again, 2 pi, pi over 2, 3 pi over 2. Okay, so now instead of going up, we're going to be going down. So that's the reflection. It's just flipping over across the x-axis. So that's what I'm thinking in my head. I'm thinking that's my graph right there. Now let's me find my critical points here. So 2 pi, because of this guy, pi over 2, 3 pi over 2. Once you make a few of these graphs, then it becomes very similar. Okay, y scale, so I'm going to go 1, 2, 3, 1, 2, 3. That's positive 3, that's negative 3. I gave my scale for my y values, and I'm done. Here it is. 0, 0, still 0, 0. I'm going downward this time. There's my dot there. Back up to 0. Up to my maximum value. In this case, it's 3 now. And back down to 0. And there's my graph. I am done. Come back up. Like that. And that's a graph of my sine function. Dun, da, da, da. Okay, now comes up is how does this get shortened and what happens here? So in this case, it's going to go, let's go with a positive 3 this time because we dealt with the, so I'm going to go with this one here. Now it's going to be 2x. So 3 sine of 2x. That's what I got there. Let's do this. Let's see if we put it together. Amplitude, absolute value of A, absolute value of 3, 3. Done. Period is 2 pi divided by B. In this case, here, I'm sorry, I should have labeled them here, A and B. In this case, it's 2 pi divided by 2, so this time my period has changed just to a pi value. Reflection, yes or no? No, there's no reflection because that's a positive value. Okay, phase shift, vertical shift later on. So since there is no let me jump back real quick here. Original boom 0 0 to the 1 to the 0 to the negative 1 back to 0. Original graph. So now let's start graphing this stuff. So first things first, no reflection. So I know I'm going to be graphing to the maximum, then down to the minimum, back to 0. Now we got our pi value. In this case, pi is going to be right here. That's what our cycle is, or our period is in terms of. So I got to go all this by the time I get to pi. So if I take half of that, it would be pi over 2. Take half of that, it would be pi over 4. So if I take pi over 4 as my unit value, this would be 2 pi over 4. Perfect, because that's half. This would be 3 pi over 4. I might as well write that in. And it makes sense because that would be 4 pi over 4 right there. Sweet. Okay. Now my amplitude, I'm going to do that by fixing my tick marks for my y-axis, and I can erase all this now. There's no need to have that in there. Okay, got it. There it is. So I divide up into 4 pieces. I start off with the 0, 0. I go up to the maximum value. Now at pi over 4. All right, but once I scale this, that's all I need. I got it all scaled. So down to my minimum value and back up to 0. And there's my graph of sine. All right, so then another question comes up, which we'll answer in just a bit here. There it is. Boom. That's cool. All right. And we got to handle this here because this is, whoa, I did not do an extra slide here. 1 second here. Let me put in an extra slide. Got to do this next one because this is so cool. All right, next slide is this one right here. This will be the last one because I'm running out of slides. 3 sine of pi x. Question is, how do you get rid of the numbers there along the x-axis with pi's in them? Because we don't normally think of time as pi. So some examples here. What the sine curve, cosine curve, what these trigonometric functions model in our world is anything that goes up and down in a very rhythmic pattern. So like maybe the best way to do it is temperature. Temperature does that. Temperature in the summertime, the highest temperature, it goes up, and then in the wintertime, the highest temperature is very low. So it follows this little pattern. And summer, winter comes and goes, and we have that little pattern. And those, we can't say that occurs in so many pi days, right? That does not make sense. You don't say, oh yeah, that's going to occur there, right? You have to be in terms of, in fact, for a year, you should be in terms of 365 days. So there's no pi inside 365. So in this case, how do you get rid of the pi values? Or even another example here. Say you had a spring like this connected to a weight. This is one of the ones in the textbook. And how about if you pull down this weight and then you let go? Well, if you pull down the weight, let go, obviously it's going to go up to a higher value. It's going to come down like this. It's going to go like this, right? And for a while, it's going to go like that. So yes, there it is. It's up and down motion, right? Up and then down and up and then down. So you got this motion. But again, we don't count this. We don't say, oh, pi over 2, pi over 2. No, it's going to be in terms of seconds. Maybe like every 2 seconds it's going to go up and then come back down. Or every 1 second it's going to do that. So there's the intro to it. So let's go for it. Let's start graphing this guy. Amplitude. Amplitude is absolute value of A. Absolute value of 3 is 3. Given. Good. Period. Period is 2 pi divided by b. In this case, that's exactly what I want right there. It is going to be divided by pi. In this case, the pi's cancel. And we got ourselves just a good old-fashioned 2 along my x-axis. That's how you get rid of those things. So now this could be in terms of 2 seconds. It could be in terms of 2 minutes, 2 years, right? 2 decades, 2 milliseconds. So if you're talking about seconds, this is perfect for that spring, right? You let go of the spring, it goes up, and then it comes back down. Goes up and comes back down in a matter of 2 seconds or so. Grandfather clock would be an awesome example there. When you have a grandfather clock, the pendulum on a grandfather clock, it takes 1 second to get to here, and then it takes 1 second to get back. That's how a grandfather clock keeps time. And so it should be hitting each of the corners on every single second. All right, to reflection. Do we have a reflection? And the answer is no. No reflection because the 3 is positive to begin with. Phase shift, vertical shift, handled later in the course. Okay, so I have my sine curve in my mind. Boom. Originally, it goes out to 2 pi, pi over 2. Once you've graphed this like 10 times, you have a very good sense of the sine curve. Boom. Hill valley. That's what we call it. A hill valley for the sine. Okay, so let me erase this just so I can have more room here. Okay, so let's go for it here. So the way we do this is no reflection. So it's going to go up and then down. Perfect. Let's set our period now. Period is going to be 2. 2 seconds, 2 years, 2 milliseconds. There it is. Take half of 2 would be a 1. Take half of that would be a half. So if that's half and that's 1, that means this has to be 3 halves. Set our amplitude 3. So now notice the scale on my y-axis is way different than the scale on my x-axis. All right, I got my critical points, or at least my values for the critical points. I have my graph in front of me. Perfect. Here we go. So 0, 0 still stays 0, 0. Goes up to the top. In this case, it's 3. Goes back down to 0 midway through. Goes down to my lowest point right over here, and then back up to the 0 marker when we hit 2. And this is one cycle of a sine function. Boom. Okay, we should do this. The cosine function, what does that look like initially? Right? I think you guys have seen it in the book. But the cosine function still does 2 pi. In fact, sine and cosine have a period of 2 pi. Tangent has a period of only pi. So if you were to graph a cosine curve, There it is. 1, -1. It starts off high for cosine, and it goes down low halfway through, comes back up. So this one, again, we worked with sine during this video, but cosine function would be that one right there. And that we do that. We manipulate that if it's multiplied by 3. If there's other values, multiplying x, and that changes the same way as the sine curve. Hopefully this was helpful to you, and I wish you the best.